Close your eyes and let your mind drift into the infinite expanse of the cosmos. Picture yourself floating weightlessly, surrounded by the gentle hum of the universe. Above you, the sun, our cosmic heartbeat, pulses with a rhythm that has shaped life on Earth for billions of years. Every 11 years, this celestial giant undergoes a mysterious transformation, a cycle of energy and calm that dances to the tune of its own cosmic melody. Tonight, we invite you to journey with us into the heart of this solar rhythm, a story of light, fire, and quiet slumber that stretches across the stars. As we explore the sun's 11-year cycle, let its soothing rhythm guide you into a state of deep relaxation, where the mysteries of the universe unfold like a lullaby written in starlight. Where are you joining us from, and what time is it there? Let the vastness of space cradle you as we begin this cosmic sleep story together. Now, let us turn our gaze to the sun, the radiant heart of our solar system. For billions of years, this glowing sphere of energy has been the lifeblood of our planet, casting its golden light across the vastness of space. Without the sun, life as we know it would simply not exist. Its warmth nurtures the plants that grow beneath our feet. Its light guides the cycles of day and night, and its energy fuels the very air we breathe. But the sun is more than just a source of light and warmth. It is a cosmic conductor, orchestrating a symphony of rhythms that ripple across the solar system. Every 11 years, the sun's activity rises and falls in a cycle that shapes the world around us in ways both subtle and profound. From the shimmering auroras that dance in the polar skies to the delicate balance of Earth's climate, the sun's influence is everywhere. Even the technology we rely on, from satellites to power grids, is touched by the sun's ever-changing moods. As we drift deeper into this cosmic story, let the sun's steady heartbeat remind you of the interconnectedness of all things, a reminder that we are all part of a grand, celestial dance. As we journey deeper into the sun's story, let us uncover the rhythm that defines its existence, the solar cycle. Picture this cycle as the sun's heartbeat, a steady pulse that repeats every 11 years. During this time, the sun transitions between two distinct phases, the solar maximum and the solar minimum. The solar maximum is a time of heightened activity, where the sun's surface becomes a stage for dramatic displays of energy. Sunspots, those dark patches on the sun's face, multiply, and solar flares burst forth like cosmic fireworks. This is the sun at its most dynamic, a period of intense magnetic activity that sends ripples across the solar system. But just as the tides ebb and flow, the sun's energy eventually wanes, leading to the solar minimum. This is a quieter phase, a time of cosmic calm where sunspots become rare and the sun's surface appears almost serene. Yet, even in this stillness, the sun's influence persists, a gentle reminder of its enduring presence. These alternating phases are not random, but part of a carefully choreographed dance, driven by the sun's magnetic field. Over the course of 11 years, this magnetic field flips, with the north and south poles swapping places, marking the completion of one cycle and the beginning of another. This rhythm, though invisible to the naked eye, shapes the world around us in profound ways. It influences the auroras that paint the night sky, the strength of solar winds that brush against Earth's atmosphere, and even the stability of our communication systems. As we drift further into this cosmic tale, let the sun's steady rhythm remind you of the delicate balance that governs our universe, a balance that connects us all in an intricate web of light and energy. Now, let us turn our gaze to one of the most fascinating features of the sun's surface, sunspots. Imagine these as the sun's freckles, dark patches that appear and disappear in a rhythmic dance across its glowing face. Sunspots are cooler regions on the sun's surface, created by intense magnetic activity that disrupts the flow of heat from the interior. These magnetic knots twist and tangle, creating areas where the temperature drops slightly, making them appear darker against the sun's bright backdrop. Sunspots are not just random marks, they are key players in the solar cycle. Their numbers rise and fall in sync with the sun's 11-year rhythm. During the solar maximum, sunspots multiply, dotting the sun's surface like a cosmic mosaic. They cluster in groups, sometimes growing larger than Earth itself, and their presence signals a time of heightened solar activity. But as the sun transitions to the solar minimum, these dark patches become scarce, and the sun's face grows quieter, almost serene. What makes sunspots truly remarkable is their role as markers of the sun's magnetic heartbeat. Each sunspot is a window into the sun's inner workings, revealing the complex interplay of magnetic forces that drive the solar cycle. They often appear in pairs, with one spot having a magnetic north polarity and the other a south polarity, like cosmic twins. Over time, as the solar cycle progresses, the polarity of these spots flips, mirroring the sun's larger magnetic reversal. Though they may seem small against the vastness of the sun, sunspots have a profound impact on our solar system. They are the birthplaces of solar flares and coronal mass ejections, powerful bursts of energy that can ripple across space and influence Earth's environment. By studying sunspots, scientists gain insights into the sun's behavior, helping us better understand its rhythms and predict its effects on our planet. As we marvel at these dark, mysterious patches, let them remind us of the sun's dynamic nature, a celestial body that is both constant and ever-changing, a source of light and life, and a cosmic clock that ticks with the precision of an 11-year rhythm. As we journey deeper into the sun's 11-year rhythm, we arrive at a time of extraordinary energy and spectacle, the solar maximum. Picture this as the sun's grand performance, a period when its magnetic activity reaches its peak and the stage is set for cosmic fireworks. During this phase, the sun's surface becomes a bustling hub of activity, with sunspots multiplying and clustering in vibrant groups. These dark patches, often larger than our own planet, serve as the epicenters of immense magnetic storms, where the sun's energy is unleashed in dazzling displays. Solar flares, one of the most dramatic phenomena of the solar maximum, erupt from these sunspots like bursts of light and heat. These explosive events release energy equivalent to millions of hydrogen bombs in mere minutes, sending shockwaves of radiation across the solar system. The flares light up the sun's atmosphere, creating arcs and loops of glowing plasma that stretch thousands of miles into space. It's as if the sun is painting the cosmos with its fiery brushstrokes, a breathtaking reminder of its power and dynamism. But the solar maximum doesn't stop there. This is also the time when coronal mass ejections, or CME, become more frequent. These massive eruptions of solar material hurl billions of tons of charged particles into space at incredible speeds. When directed toward Earth, these particles can interact with our planet's magnetic field, sparking geomagnetic storms that light up the night sky with auroras. Imagine curtains of green, pink, and purple dancing across the polar skies, a direct gift from the sun's fiery outbursts. The solar maximum is not just a visual spectacle, it's a time of heightened influence on our technological world. Solar flares and CMEs can disrupt satellite communications, affect power grids, and even pose risks to astronauts in space. Yet, despite these challenges, this phase of the solar cycle offers scientists a unique opportunity to study the sun's behavior up close. By observing the solar maximum, we gain valuable insights into the sun's magnetic field, its energy dynamics, and its impact on the solar system. As we witness this cosmic crescendo, let it remind us of the sun's dual nature, a source of both beauty and power. The solar maximum is a testament to the sun's vitality, a time when its energy shines brightest and its rhythms echo across the universe. And as we marvel at this celestial spectacle, we are reminded of our connection to the cosmos, where even the smallest spark can illuminate the vastness of space. Now, as the sun's grand performance fades, we enter a time of quiet reflection, the solar minimum. This is the sun's serene interlude, a period of calm that follows the fiery crescendo of the solar maximum. Imagine the sun's surface, once alive with sunspots and flares, now settling into a tranquil stillness. The dark patches that once dotted its face grow sparse, and the magnetic storms that once raged subside, leaving behind a peaceful, almost meditative atmosphere. During the solar minimum, the sun's activity slows to a gentle rhythm, like the quiet breathing of a sleeping giant. Solar flares become rare, and coronal mass ejections are few and far between. The sun's magnetic field, once twisted and turbulent, relaxes into a simpler, more orderly pattern. It's as if the cosmos itself takes a deep breath, basking in the stillness of this cosmic slumber. This phase is not without its own beauty. Without the constant bursts of energy, the sun's corona, the outermost layer of its atmosphere, appears smoother and more uniform. The absence of dramatic flares and eruptions allows us to see the sun in a different light, revealing its quieter, more contemplative side. It's a reminder that even the most dynamic forces in the universe have moments of rest, a balance between chaos and calm. The solar minimum also brings a sense of stability to our technological world. With fewer solar flares and CMEs, the risks to satellites, power grids, and astronauts diminish. This period of reduced activity offers scientists a chance to study the sun's baseline behavior, providing valuable insights into its long-term patterns and cycles. It's a time for observation and understanding, a pause in the sun's rhythm that allows us to reflect on its enduring influence. Yet, even in this stillness, the sun remains a source of wonder. The solar minimum is not a time of absence, but of subtlety. The solar wind, though gentler, continues to flow, carrying the sun's energy across the solar system. Auroras may be less frequent, but when they do appear, they shimmer with a quiet elegance, a reminder of the sun's ever-present connection to Earth. As we contemplate the solar minimum, let it remind us of the balance that exists in the universe. Just as the solar maximum dazzles with its energy and spectacle, the solar minimum offers a moment of peace and reflection. Together, these phases form the heartbeat of the sun, a rhythm that echoes through the cosmos, connecting us to the ebb and flow of celestial time. And as we witness this quiet cosmic slumber, we are reminded that even in stillness, there is beauty, and even in calm, there is power. As the sun awakens from its quiet slumber, it begins to stir with a new kind of energy, a dance of light and power that captivates the cosmos. Solar flares, the sun's most dramatic performances, burst forth with an intensity that defies imagination. These brilliant eruptions are born from the sun's magnetic fields, twisted and tangled until they snap, releasing an explosion of energy that can outshine entire galaxies for a brief, breathtaking moment. Picture the sun's surface, a canvas of fire and plasma, suddenly illuminated by a flash of light so bright it can be seen across the solar system. Solar flares are like cosmic fireworks, their energy radiating across millions of miles, painting the void with streaks of light and heat. In mere minutes, a single flare can release as much energy as billions of atomic bombs, a testament to the sun's immense power. These flares are not just displays of raw energy, they are also works of art. The light they emit spans the entire spectrum, from the invisible X-rays that pierce through space to the vibrant ultraviolet rays that paint the sun's atmosphere in dazzling colors. Each flare tells a story of magnetic tension and release, a dance of forces that shapes the sun's dynamic personality, but the beauty of solar flares is matched by their impact. When a flare erupts, it sends a wave of charged particles racing through space, a solar wind that can reach Earth in just a matter of hours. These particles interact with our planet's magnetic field, creating geomagnetic storms that light up the skies with auroras. The same energy that dazzles the cosmos also connects us to the sun, a reminder of our place in its vast, intricate web. Yet, solar flares are not without their challenges. Their intense radiation can disrupt satellites, interfere with communication systems, and even pose risks to astronauts in space. But even in their unpredictability, they offer scientists a chance to study the sun's inner workings, unlocking secrets about its magnetic fields and the forces that drive its cycles. As we witness the dance of solar flares, we are reminded of the sun's dual nature, both a source of life and a force of immense power. These eruptions are not just bursts of energy, they are expressions of the sun's vitality, a reminder that even in the vastness of space, there is a rhythm, a pulse, a dance that connects us all. And as we watch these cosmic performances, we are drawn into the story of the sun, a story of light, energy, and the endless wonder of the universe. Now, let us turn our gaze to another breathtaking phenomenon, born from the sun's restless energy, coronal mass ejections. Imagine the sun exhaling a colossal breath, a burst of solar wind so vast it carries billions of tons of charged particles into space. These eruptions, known as coronal mass ejections, are among the most powerful events in our solar system, capable of reshaping the very fabric of space weather. Unlike the sudden brilliance of solar flares, Coronal mass ejections unfold more slowly, building up over hours or even days. They begin in the sun's corona, the outermost layer of its atmosphere, where magnetic fields twist and snap, releasing a massive cloud of plasma. This cloud, glowing with the sun's fiery essence, races outward at speeds of millions of miles per hour, carrying with it the sun's magnetic field and a torrent of charged particles. When these particles reach Earth, they interact with our planet's magnetic field, creating geomagnetic storms that can light up the night sky with auroras. These shimmering displays are not just beautiful, they are a testament to the sun's far-reaching influence. But coronal mass ejections are more than just cosmic spectacles. They are also a reminder of the sun's power to shape our technological world. The intense bursts of energy from these events can disrupt satellites, interfere with power grids, and even pose risks to astronauts in space. Yet, despite their potential for disruption, coronal mass ejections also offer scientists a unique opportunity to study the sun's magnetic fields and the forces that drive its cycles. By observing these events, we gain insights into the sun's inner workings and its role in the broader cosmos. Coronal mass ejections are a reminder of the sun's dual nature, both a source of life and a force of immense power. They are the sun's cosmic breath, a testament to its vitality and its ability to shape the universe around it. As we watch these massive eruptions unfold, we are drawn deeper into the story of the sun, a story of light, energy, and the endless wonder of the cosmos. And as we marvel at the sun's cosmic breath, we are reminded of the delicate balance that connects us to our star, a balance of beauty, power, and the ever-present rhythm of the solar cycle. Now, let us venture deeper into the heart of the sun's mysteries, where invisible forces weave a tapestry of energy and motion, the sun's magnetic field. Picture a vast, intricate web stretching across the solar surface, its threads twisting and turning in a cosmic dance. This magnetic field is not just a passive feature, it is the driving force behind the sun's dynamic behavior, shaping the very rhythm of the solar cycle. The sun's magnetic field is born from the churning motions of its plasma, a hot, electrically charged gas that flows and swirls deep within its core. As this plasma moves, it generates electric currents, which in turn create magnetic fields. These fields rise to the surface, forming loops and arcs that arch high above the sun's atmosphere. Over time, these loops twist and tangle, building up energy until they snap, releasing bursts of solar activity like flares and coronal mass ejections. This magnetic web is not static. It is constantly shifting and evolving. During the solar maximum, the field becomes particularly chaotic, with sunspots and active regions marking areas of intense magnetic activity. These sunspots are like knots in the web, where the magnetic field is so strong that it suppresses the flow of heat, creating cooler, darker patches on the sun's surface. As the solar cycle progresses toward the minimum, the field gradually calms, becoming more orderly and less turbulent. The sun's magnetic field also extends far beyond its surface, reaching out into the solar system as the solar wind. This wind carries the sun's magnetic influence to the farthest reaches of space, shaping the environment around planets, moons, and even spacecraft. It is this magnetic connection that allows the sun to interact with Earth's magnetosphere, creating phenomena like auroras and geomagnetic storms. Yet, for all its power and influence, the sun's magnetic field remains a source of mystery. Scientists are still unraveling the complexities of how it forms, how it drives the solar cycle, and why it behaves the way it does. Each twist and turn of this cosmic web offers new clues, drawing us closer to understanding the sun's hidden rhythms. As we explore the sun's magnetic field, we are reminded of the delicate balance that governs our star, a balance of chaos and order, of creation and destruction. It is a reminder that even in the vastness of space, there is a pattern, a rhythm, a story waiting to be told. And as we follow the threads of this cosmic web, we are drawn ever deeper into the mystery of the sun's eternal dance. Now, let us drift into the realm of the solar wind, a gentle yet powerful stream that flows outward from the sun, carrying its energy and influence across the vast expanse of space. Imagine a cosmic breeze, invisible to the eye but ever present, made up of charged particles, electrons, and protons that race away from the sun at incredible speeds. This solar wind is not just a random flow, it is a continuous outpouring of the sun's essence, a reminder of its dynamic and ever-active nature. The solar wind begins its journey in the sun's corona, the outermost layer of its atmosphere. Here, the intense heat and magnetic forces propel these charged particles outward, creating a stream that travels at speeds of hundreds of kilometers per second. As it moves through the solar system, the solar wind carries with it the sun's magnetic field, extending its influence far beyond the boundaries of our star. When this cosmic breeze reaches Earth, it encounters our planet's magnetosphere, a protective shield generated by Earth's own magnetic field. The interaction between the solar wind and the magnetosphere is a delicate dance of forces. Some particles are deflected, flowing around Earth like water around a rock in a stream. Others are funneled toward the poles, where they collide with atoms in the atmosphere, creating the dazzling light shows we know as auroras. But the solar wind's influence doesn't stop there. It shapes the very environment of space around our planet, creating a dynamic region known as the magnetosphere. This region is constantly in flux, responding to the ebb and flow of the solar wind's intensity. During periods of heightened solar activity, such as solar storms, the solar wind can compress the magnetosphere, triggering geomagnetic storms that can affect satellites, communication systems, and even power grids on Earth. Despite its potential for disruption, the solar wind also serves as a vital link between the sun and Earth. It is a reminder of the sun's constant presence in our lives, a connection that transcends the vast distances of space. Through the solar wind, we are reminded that we are part of a larger cosmic system, one where the rhythms of the sun shape the environment of our planet in ways both subtle and profound. As we contemplate the solar wind, we are drawn into the intricate web of connections that bind the sun and Earth together. It is a gentle yet powerful force, a cosmic breeze that whispers the story of our star's enduring influence. And as we listen to this story, we are reminded of the beauty and complexity of the universe, a place where even the smallest particles can carry the echoes of a star's eternal dance. Now, let us turn our gaze to one of the most breathtaking displays in the night sky, the auroras. These shimmering curtains of light, dancing in hues of green, pink, purple, and blue, are not just a spectacle for the eyes, but a direct result of the sun's activity. Picture the night sky as a canvas, and the sun as the artist, painting with strokes of charged particles and magnetic energy. Auroras, often called the northern and southern lights, occur when the solar wind, the same cosmic breeze we've been exploring, interacts with Earth's magnetosphere. As the charged particles from the sun are funneled toward the poles by Earth's magnetic field, they collide with atoms and molecules in the upper atmosphere. These collisions release energy in the form of light, creating the vibrant colors that ripple across the sky. The most common color, a vivid green, comes from oxygen atoms excited by the solar particles. Higher in the atmosphere, where the air is thinner, oxygen can produce a rare red glow. Nitrogen, on the other hand, contributes shades of blue and purple, adding depth and variety to the display. The result is a celestial ballet, a symphony of light that feels almost alive as it shifts and swirls above. But auroras are more than just a beautiful phenomenon. They are a reminder of the sun's power and its ability to reach across the vastness of space to touch our world. During periods of heightened solar activity, such as solar storms, the auroras can become even more intense, stretching farther from the poles and lighting up the skies of regions that rarely witness them. For those lucky enough to witness an aurora, the experience is nothing short of magical. Standing beneath a sky alive with color, it's easy to feel a deep connection to the cosmos, as if the universe itself is putting on a show just for you. The auroras remind us that even in the quiet of night, the sun's influence is ever present, weaving its light into the fabric of our world. As we marvel at these celestial wonders, we are reminded of the delicate balance that allows life to thrive on Earth. The same solar wind that creates the auroras also shapes our planet's environment, influencing everything from our climate to our technology. It is a dance of forces, both beautiful and powerful, that connects us to the rhythms of the sun and the larger universe. And so, as the auroras fade and the night sky returns to stillness, we carry with us a sense of awe and gratitude. For in these fleeting moments of light, we glimpse the enduring connection between our world and the star that gives it life. The auroras are not just a light show, they are a story written in the language of the cosmos, and one that continues to inspire wonder in all who witness it. As we drift further into the mysteries of the sun's rhythms, let us now turn our attention to its subtle yet profound influence on Earth's climate. While the sun's light and warmth are the very foundation of life on our planet, its cycles also play a quiet but significant role in shaping the weather patterns and temperatures we experience. The solar cycle, with its ebb and flow of activity, can influence Earth's climate in ways that are both fascinating and complex. During periods of heightened solar activity, such as the solar maximum, the sun emits slightly more energy. This increase in solar radiation can lead to subtle shifts in global temperatures, warming the atmosphere just enough to alter weather patterns. Conversely, during the solar minimum, when the sun's activity wanes, the Earth may experience a slight cooling effect. These changes, though small, can ripple through the climate system, affecting everything from ocean currents to wind patterns. For example, some studies suggest that the solar cycle may influence the behavior of the jet stream, the fast-flowing air currents that drive much of our weather. A stronger solar maximum could nudge the jet stream, leading to shifts in rainfall patterns, or even influencing the frequency of extreme weather events. The sun's impact on climate doesn't stop at temperature changes. Ultraviolet radiation, which varies with the solar cycle, can also affect the chemistry of the upper atmosphere. This, in turn, influences the formation of clouds and the distribution of heat across the planet. It's a delicate interplay where even small changes in the sun's output can have far-reaching consequences for Earth's climate. But the sun's influence is just one piece of the puzzle. Earth's climate is shaped by a multitude of factors, from volcanic eruptions to human activities. The solar cycle adds another layer of complexity, reminding us of the intricate connections between our planet and the star that sustains it. As we reflect on these subtle yet powerful influences, we gain a deeper appreciation for the sun's role in our world. Its rhythms, though often unnoticed, are woven into the fabric of our climate, shaping the environment in ways that are both profound and beautiful. And so, as we continue our journey through the mysteries of the solar cycle, let us carry with us this understanding of the sun's quiet yet enduring impact on our planet. It is a reminder that even in the vastness of space, the connections between the sun and Earth are as close as they are awe-inspiring. Now, let us turn our gaze to a more dramatic aspect of the sun's activity: solar storms. These powerful eruptions are among the most awe-inspiring displays of the sun's energy, showcasing its raw and untamed fury. Solar storms occur when the sun releases massive bursts of charged particles and magnetic fields into space, often triggered by the sudden release of energy stored in its twisted magnetic fields. When these storms are directed toward Earth, they can create spectacular light shows in the form of auroras, painting the night sky with shimmering curtains of green, red, and purple. But beyond their beauty, solar storms carry a force that can disrupt the delicate balance of our modern technological world. The most intense solar storms, known as coronal mass ejections, can send billions of tons of solar material hurtling toward Earth at incredible speeds. When these particles collide with our planet's magnetic field, they can induce powerful electric currents in the ground and in our power grids. In extreme cases, this can lead to widespread blackouts, damaging transformers and leaving entire regions without electricity. Communication systems are also vulnerable. Solar storms can interfere with radio signals, disrupt satellite operations, and even pose risks to astronauts in space. The charged particles can penetrate spacecraft, potentially harming sensitive equipment and exposing crew members to higher levels of radiation. Yet, despite their potential for disruption, solar storms are a reminder of the sun's immense power and the dynamic nature of our solar system. They highlight the delicate balance between the sun's life, giving energy, and its capacity for chaos. For scientists, these storms are both a challenge and an opportunity, a chance to better understand the sun's behavior and improve our ability to predict and mitigate their effects. As we marvel at the sun's fury, we are reminded of our place in the cosmos. The same star that nurtures life on Earth also holds the power to reshape our world in an instant. It is a humbling thought, one that deepens our appreciation for the sun's dual nature, both a source of life and a force of incredible energy. With this understanding, we prepare to explore another fascinating aspect of the sun's influence, its role in shaping the myths and rituals of ancient cultures, where its power was revered and its mysteries celebrated. As we journey further into the sun's story, let us step back in time to explore how ancient civilizations viewed this celestial giant. For countless generations, the sun was not just a star in the sky, it was a deity, a symbol of life, and a source of profound mystery. Across cultures and continents, the sun's rhythms and cycles were woven into the very fabric of human existence, shaping myths, rituals, and even the foundations of early science. In ancient Egypt, the sun god Ra was believed to sail across the sky each day in a golden boat, bringing light and warmth to the world. His nightly journey through the underworld symbolized death and rebirth, mirroring the sun's daily disappearance and return. The Egyptians built towering obelisks and temples aligned with the sun's movements, honoring Ra as the giver of life and the ruler of time. The Inca civilization of South America revered in Tai, the sun god, as the ancestor of their rulers and the protector of their empire. The Inti Raymi festival, held during the winter solstice, celebrated the sun's return and its promise of renewed fertility for the land. The Incas' mastery of astronomy allowed them to create intricate calendars and structures like Machu Picchu, which were precisely aligned with the sun's position during key moments of the year. In ancient Greece, the sun was personified as Helios, who drove a chariot of fire across the sky each day. The Greeks also recognized the sun's cycles, using them to mark the passage of time and guide agricultural practices. Similarly, in Norse mythology, the sun was seen as a chariot pulled by horses, chased by a wolf that sought to devour it, a poetic representation of solar eclipses and the eternal struggle between light and darkness. For the Maya, the sun was central to their cosmology and daily life. Their elaborate calendar systems were based on precise observations of the sun's movements, allowing them to predict solstices, equinoxes, and even eclipses. The sun was not just a celestial body, but a divine force that governed the cycles of life, death, and renewal. These ancient cultures, though separated by vast distances in time, shared a common reverence for the sun. They saw in its cycles a reflection of their own lives' birth, growth, decline, and rebirth. The sun's predictable rhythms offered a sense of order in an often unpredictable world, and its light became a symbol of hope, power, and continuity. As we reflect on these ancient beliefs, we are reminded of the timeless connection between humanity and the sun. Its cycles, once the subject of myth and ritual, are now the focus of modern science. Yet, the awe and wonder it inspires remain unchanged. With this sense of reverence, we now turn to explore how today's scientists unravel the mysteries of the solar cycle, using tools and technologies that our ancestors could scarcely have imagined. Now, as we shift our gaze from the ancient world to the present day, let us explore how modern science has taken up the mantle of understanding the sun's enigmatic rhythms. Today, astronomers and scientists use an array of advanced tools and technologies to study the solar cycle, peeling back the layers of mystery that once captivated our ancestors. At the heart of this exploration are powerful telescopes, both on Earth and in space, ground-based observatories equipped with cutting-edge instruments capture detailed images of the sun's surface, revealing sunspots, solar flares, and other phenomena in stunning clarity. These telescopes allow scientists to monitor the sun's activity in real time, tracking changes that hint at the underlying mechanisms driving the solar cycle. But the true game changer has been the deployment of space-based observatories. Satellites like the Solar and Heliospheric Observatory, or SOHO, and the Solar Dynamics Observatory, known as SDO, orbit the Earth, providing an uninterrupted view of the sun. Free from the distortions of Earth's atmosphere, these satellites capture high-resolution images and data across multiple wavelengths of light, offering insights into the sun's magnetic field, its outer atmosphere, and the dynamics of solar storms. One of the most fascinating tools in this scientific arsenal is the magnetograph, an instrument that maps the sun's magnetic field. By studying these magnetic patterns, scientists can predict the emergence of sunspots and the likelihood of solar flares or coronal mass ejections. This knowledge not only deepens our understanding of the solar cycle, but also helps us prepare for the potential impacts of solar activity on Earth's technology and infrastructure. Another breakthrough has come from helioseismology, the study of solar vibrations. Just as earthquakes reveal the inner structure of our planet, the sun's oscillations provide clues about its internal dynamics. By analyzing these vibrations, scientists can infer the temperature, density, and movement of material deep within the sun, shedding light on how energy is transported from its core to its surface. Modern science has also embraced the power of computer modeling. Supercomputers simulate the complex interactions of plasma, magnetic fields, and radiation within the sun, allowing researchers to test theories and predict future solar activity. These models are continually refined as new data becomes available, bringing us closer to unraveling the sun's secrets. Yet, despite these advancements, the solar cycle remains a puzzle with many pieces still missing. Why does the cycle last approximately 11 years? What causes the irregular patterns in solar activity? These questions drive ongoing research, inspiring scientists to push the boundaries of our knowledge. As we marvel at the tools and techniques of modern astronomy, we are reminded of the enduring fascination the sun holds for humanity. From ancient myths to cutting-edge science, our quest to understand this celestial giant continues, bridging the past and the future in a timeless journey of discovery. And now, as we look ahead, let us turn our attention to what the future holds for the sun itself, a story of cosmic evolution that spans billions of years. As we journey forward in time, let us peer into the distant future of our sun, a future that stretches across billions of years and holds profound changes for this celestial beacon. The sun, as we know it today, is a stable and life-giving star, but like all stars, it is destined to evolve. Over the next 5 billion years, the sun will undergo a dramatic transformation, one that will reshape not only its own existence, but also the fate of our solar system. The first stage of this cosmic journey will see the sun gradually exhaust the hydrogen fuel in its core. As this fuel runs low, the core will contract under its own gravity, causing the outer layers to expand and cool. The sun will swell into a red giant, growing hundreds of times larger than its current size. During this phase, its surface will glow with a reddish hue, and its outer layers will extend far beyond the orbit of Mercury, possibly even engulfing Venus and Earth. As the sun expands, its cycles of activity will also change. The familiar 11-year solar cycle, driven by the sun's magnetic field, will become less predictable. The magnetic field itself will weaken as the sun's internal dynamics shift, leading to fewer sunspots and solar flares. Yet, even as its activity diminishes, the sun's outer layers will grow more turbulent, ejecting vast amounts of material into space in a process known as stellar winds. Eventually, the sun will shed its outer layers entirely, leaving behind a dense, glowing core known as a white dwarf. This remnant will be surrounded by a beautiful shell of gas and dust, called a planetary nebula, which will slowly dissipate into the cosmos. The white dwarf will continue to radiate heat and light for trillions of years, but it will no longer undergo the cycles of activity we associate with the sun today. This cosmic journey reminds us of the impermanence of even the most enduring celestial bodies. The sun, which has been a constant presence in our lives and the lives of countless generations before us, will one day fade into a new form. Yet, its story is far from over. The material it sheds will become part of the interstellar medium, the raw material for new stars and planets, continuing the cycle of creation and destruction that defines the universe. As we reflect on the sun's future, we are reminded of the vast scales of time that govern the cosmos. The sun's evolution is a testament to the dynamic and ever-changing nature of the universe, a reminder that even the stars are not eternal. And now, as we turn our gaze back to the present, let us consider how the sun's cycles and rhythms continue to shape our world today, influencing everything from our technology to our exploration of space. As we shift our focus to the present and the near future, let's explore how the sun's rhythms influence one of humanity's most daring endeavors, space exploration. The solar cycle, with its peaks and valleys of activity, plays a crucial role in shaping the challenges and opportunities faced by astronauts and mission planners alike. During periods of high solar activity, known as solar maximum, the sun becomes a more volatile neighbor. Solar flares and coronal mass ejections release bursts of radiation and charged particles into space, creating hazards for astronauts venturing beyond Earth's protective magnetosphere. These events can disrupt communication systems, damage spacecraft electronics, and pose serious health risks to crew members. To mitigate these dangers, space agencies carefully monitor solar activity, timing missions to coincide with quieter periods whenever possible. Yet, the solar cycle also offers opportunities for discovery. The increased solar activity during solar maximum provides scientists with a chance to study the sun's behavior in greater detail. Missions like NASA's Parker Solar Probe and the European Space Agency's Solar Orbiter are designed to withstand the intense heat and radiation near the sun, gathering data that helps us better understand its magnetic field, solar wind, and explosive events. These insights not only enhance our knowledge of the sun, but also improve our ability to predict and prepare for space weather, ensuring safer journeys for future explorers. The solar cycle also influences the design and operation of spacecraft. Engineers must account for the varying levels of radiation and solar wind when building satellites, probes, and crewed vehicles. Shielding materials, power systems, and communication technologies are all tailored to withstand the sun's changing moods. Even the trajectories of missions to distant planets are planned with the solar cycle in mind, as the sun's gravitational pull and radiation pressure can subtly alter a spacecraft's path over time. For astronauts living and working on the International Space Station, the solar cycle is a constant consideration. While the station orbits within Earth's protective magnetic field, it is not entirely shielded from solar radiation. During intense solar storms, crew members may take refuge in more heavily shielded areas of the station, and ground controllers adjust the station's altitude to minimize exposure. These precautions highlight the delicate balance between human ambition and the sun's immense power. As we look to the future of space exploration, from lunar bases to missions to Mars, understanding the solar cycle will be more important than ever. The rhythms of the sun will shape the timing, technology, and safety of these ventures, reminding us that even as we reach for the stars, we remain deeply connected to the star at the center of our solar system. With this in mind, let's turn our attention to the broader cosmic stage, where the sun's cycles are just one part of a much larger dance. The rhythms of the universe, from the orbits of planets to the rotation of galaxies, reveal a harmony that connects us all. As we expand our gaze beyond our solar system, let's explore how the sun's cycles fit into the grand tapestry of the universe. While the sun's 11-year rhythm is fascinating, it is just one example of the many stellar rhythms that exist among the countless stars scattered across the cosmos. Each star, like the sun, has its own unique heartbeat, shaped by its size, age, and composition. Take, for instance, red dwarf stars, the most common type of star in the galaxy. These small, cool stars burn their fuel slowly, often exhibiting cycles of activity that are far less dramatic than the sun's. Their magnetic fields, while strong, tend to produce fewer sunspots and solar flares, resulting in quieter, more stable rhythms. Yet, even these gentle stars have their moments of brilliance, occasionally flaring up with bursts of energy that can influence nearby planets. On the other end of the spectrum, massive stars burn brightly and live fast. These giants, many times larger than the sun, experience cycles of activity that are far more intense and chaotic. Their magnetic fields are incredibly powerful, generating frequent and violent eruptions that can light up entire regions of space. However, their lives are short compared to the sun's, ending in spectacular supernovae that scatter their elements across the galaxy, seeding the birth of new stars and planets. Even among stars similar to the sun, there is a remarkable diversity of rhythms. Some stars have cycles that last only a few years, while others stretch over decades. These variations are influenced by factors like rotation speed, magnetic field strength, and the presence of companion stars. For example, stars that rotate faster tend to have shorter, more active cycles, while slower rotators often experience longer, more subdued periods of activity. What makes the sun's cycle particularly intriguing is its balance between activity and stability. While it experiences periods of intense solar storms, it also enjoys long stretches of relative calm, creating an environment that has allowed life to flourish on Earth. This delicate equilibrium is not universal among stars, making the sun's rhythm both unique and essential to our existence. Yet, despite these differences, there is a universal thread that connects all stars: the fundamental processes that drive their cycles. The interplay of magnetic fields, convection, and rotation shapes the behavior of stars across the universe, from the smallest red dwarfs to the most massive giants. These shared mechanisms remind us that the sun is not an isolated phenomenon, but part of a broader cosmic symphony, where every star contributes its own melody. As we ponder the sun's place among the stars, we are reminded of the vastness and complexity of the universe. Each star, with its own rhythm and story, adds to the richness of the cosmic dance. And as we continue to study these distant suns, we gain a deeper appreciation for the unique and precious nature of our own. Now, let's turn our attention to the mysteries that still surround the sun's cycles, exploring the questions that scientists are working to answer as they unravel the secrets of our star. As we venture deeper into the heart of the sun's mysteries, we uncover questions that continue to puzzle even the most brilliant minds. While we've come to understand much about the solar cycle, there are still hidden secrets that elude us, sparking curiosity and driving scientific exploration. One of the most intriguing mysteries lies in the irregularity of the sun's cycles. While the 11-year rhythm is a well-established pattern, it's not always precise. Some cycles are shorter, others longer, and the intensity of solar activity can vary dramatically from one cycle to the next. Scientists have yet to fully explain why these fluctuations occur, though they suspect it has to do with the complex interplay of the sun's magnetic fields and internal dynamics. Another enigma is the sun's magnetic field itself. Unlike Earth's relatively stable magnetic field, the sun's is constantly shifting and twisting, creating a chaotic web of energy. This magnetic activity drives the solar cycle, but the exact mechanisms behind it remain unclear. How does the sun generate such a powerful and dynamic magnetic field? And what causes it to reverse polarity every 11 years, marking the transition from one cycle to the next? These are questions that continue to challenge researchers. Then there's the mystery of the sun's quiet periods, known as grand minima. During these times, solar activity drops to unusually low levels, sometimes lasting for decades. The most famous example is the Maunder minimum, a period in the 17th century when sunspots nearly disappeared for over 70 years. What triggers these extended lulls in activity? And how do they affect Earth's climate and environment? While scientists have some theories, the full picture remains elusive. Even the sun's internal structure holds secrets. Deep within its core, nuclear fusion generates the energy that powers the sun, but the details of how this energy travels to the surface are still being studied. Convection, currents, magnetic fields, and other processes all play a role, but the exact pathways and interactions are not fully understood. As we peel back the layers of these mysteries, we gain not only a deeper understanding of the sun, but also a greater appreciation for the complexity of the universe. Each unanswered question reminds us that there is still so much to learn, and every discovery brings us closer to unraveling the secrets of our star. Now, let's turn our gaze to the breathtaking views of the sun through telescopes, where its beauty and power are revealed in stunning detail. As we shift our focus to the sun's beauty through the lens of a telescope, a whole new world of wonder unfolds. Through these powerful instruments, the sun reveals itself not just as a distant ball of light, but as a dynamic, ever-changing celestial body, teeming with life and energy. One of the most striking features visible through a telescope is the sun's surface, known as the photosphere. Here, sunspots appear as dark, mysterious patches scattered across the glowing surface. These sunspots are cooler regions caused by intense magnetic activity, and they often cluster together, creating intricate patterns that shift and evolve over time. Watching them through a telescope feels like witnessing the sun's own heartbeat, a rhythmic dance of light and shadow, but the sun's beauty doesn't stop at its surface. Solar prominences, massive loops of glowing plasma, arch high above the sun's edge, suspended by its magnetic field. These fiery tendrils can stretch for thousands of miles, and through a telescope, they appear as delicate, glowing ribbons against the dark backdrop of space. Sometimes, these prominences erupt, sending vast amounts of material into the solar system in a breathtaking display of cosmic power. Then there are solar flares, sudden bursts of energy that light up the sun's surface like cosmic fireworks. Through a telescope, these flares appear as bright, fleeting flashes, releasing energy equivalent to millions of hydrogen bombs in mere seconds. It's a reminder of the sun's raw power and the forces that shape our solar system. Even the sun's outer atmosphere, the corona, becomes visible during a solar eclipse or with specialized telescopes. This shimmering halo of plasma extends millions of miles into space, its wispy tendrils glowing faintly against the darkness. The corona is a testament to the sun's influence, a reminder that its reach extends far beyond what we can see with the naked eye. Through the lens of a telescope, the sun transforms from a familiar star into a living, breathing entity, full of mystery and majesty. Each observation offers a glimpse into its dynamic nature, inviting us to marvel at the intricate details and the sheer scale of its beauty. Now, let's explore the sun's place within the Milky Way galaxy, where its cycles and rhythms are part of a much larger cosmic dance. As we turn our gaze beyond the sun and into the vast expanse of the Milky Way, we begin to see our star not as an isolated entity, but as a small yet vital part of a much grander cosmic tapestry. The sun, with its rhythmic cycles and dynamic energy, is just one of hundreds of billions of stars that make up our galaxy. Each of these stars, like the sun, has its own story, its own rhythm, and its own place in the intricate dance of the cosmos. The Milky Way, a sprawling spiral galaxy, stretches across an unimaginable distance of about 100,000 light-years. Within this vast structure, the sun orbits the galactic center, completing one full journey roughly every 230 million years. This movement, known as the galactic year, is a slow, steady rhythm that mirrors the sun's own 11-year cycle on a much grander scale. As the sun travels through the galaxy, it doesn't move alone. It carries with it the entire solar system, including Earth and all the other planets, asteroids, and comets. Together, they glide through the interstellar medium, a thin soup of gas and dust that fills the space between stars. This journey isn't a straight path, but a gentle, undulating motion, influenced by the gravitational pull of other stars and the dark matter that permeates the galaxy. The sun's cycles, from the rise and fall of sunspots to the bursts of solar flares, are not just isolated events. They are part of a larger pattern, influenced by the sun's position within the Milky Way and its interactions with the surrounding environment. For instance, as the sun moves through denser regions of the galaxy, it may encounter more cosmic rays, which can subtly affect its magnetic field and, in turn, its activity cycles. Even more fascinating is the way the sun's cycles align with the rhythms of the galaxy itself. Just as the sun's magnetic field flips every 11 years, the Milky Way undergoes its own cycles of star formation, supernova, and galactic winds. These processes, though occurring on vastly different timescales, are all interconnected, part of the same cosmic symphony. In this grand dance, the sun plays a humble yet essential role. Its energy sustains life on Earth, while its cycles influence the space, weather that shapes our planet's environment. At the same time, the sun is shaped by the galaxy around it, a reminder that no star exists in isolation. Together, the sun and the Milky Way tell a story of connection, of cycles within cycles, and of the endless interplay between the small and the vast. Now, let's delve into how the sun's activity influences space weather, shaping the environment not just around Earth, but throughout the solar system. As we shift our focus to the sun's influence on space weather, we uncover a dynamic interplay between our star and the environment it shapes. The sun's activity, driven by its 11-year cycle, doesn't just affect its surface, it ripples outward, influencing the entire solar system. This constant flow of energy and particles creates what we call space weather, a phenomenon that impacts everything from satellites orbiting Earth to the auroras dancing in our skies. At the heart of space weather are solar flares and coronal mass ejections, powerful bursts of energy and matter that erupt from the sun's surface. During periods of high solar activity, such as the solar maximum, these events become more frequent and intense. When a coronal mass ejection is directed toward Earth, it sends a wave of charged particles racing through space. Upon reaching our planet, these particles interact with Earth's magnetic field, triggering geomagnetic storms. These storms can have a range of effects, from the beautiful to the disruptive. On one hand, they create the stunning auroras that light up the polar skies, painting the night with shimmering greens, reds, and purples. On the other hand, they can interfere with satellite communications, disrupt power grids, and even pose risks to astronauts in space. The sun's activity, in this way, is both a source of wonder and a reminder of its immense power. Radiation levels in space are also influenced by the solar cycle. During the solar minimum, when the sun is quieter, cosmic rays from distant parts of the galaxy can more easily penetrate the solar system. These high-energy particles can affect both technology and living organisms, making space travel more challenging during these periods. Conversely, During the solar maximum, the sun's increased activity helps shield the solar system from some of these cosmic rays, creating a more protective environment. The sun's magnetic field plays a crucial role in shaping space weather. As the sun's magnetic field twists and turns, it generates complex patterns that influence how energy and particles are released into space. These magnetic interactions can create solar wind, a steady stream of charged particles that flows outward from the sun. When the solar wind reaches Earth, it compresses our planet's magnetic field on the side facing the sun and stretches it into a long tail on the opposite side. This constant push and pull is a key driver of space weather. Understanding space weather is not just an academic pursuit, it's essential for our modern way of life. Satellites that enable global communication, navigation systems, and weather forecasting are all vulnerable to the sun's activity. By studying the solar cycle and its effects, scientists can better predict space weather events, helping to protect our technology and infrastructure. As we continue to explore the sun's rhythms, we gain a deeper appreciation for its role in shaping the environment around us. From the dazzling auroras to the invisible forces that influence our technology, the sun's impact on space weather is a testament to its dynamic and ever-changing nature. Now, let's turn our attention to how the sun's cycles subtly influence life on Earth. From biological rhythms to cultural traditions, the sun's rhythms, though often unnoticed, weave themselves into the very fabric of human life, shaping our days, our bodies, and even our cultures in ways both subtle and profound. As we explore this connection, we begin to see how deeply intertwined we are with the cosmic dance of our star. One of the most direct ways the sun influences us is through our biological rhythms. The rising and setting of the sun each day governs our circadian rhythm, the internal clock that regulates our sleep-wake cycle. This natural rhythm aligns our bodies with the patterns of light and darkness, helping us feel alert during the day and sleepy at night. Even artificial light, which mimics the sun's glow, can affect this delicate balance, highlighting how deeply our lives are tied to the sun's presence. Beyond daily cycles, the sun's longer rhythms also leave their mark. Seasonal changes, driven by Earth's tilt and orbit around the sun, influence everything from our energy levels to our moods. In winter, shorter days and reduced sunlight can lead to feelings of lethargy or even seasonal affective disorder for some. In contrast, the longer, sunlit days of summer often bring a sense of vitality and renewal. These shifts remind us that the sun's cycles are not just astronomical phenomena, they are deeply personal, shaping how we feel and live. Culturally, the sun has been a source of inspiration and reverence for countless generations. Ancient civilizations built monuments aligned with the sun's movements, such as Stonehenge and the pyramids of Egypt, to mark solstices and equinoxes. Festivals celebrating the sun's return after the winter solstice, like Yule and Inti Raymi, highlight its importance in human traditions. Even today, many cultures honor the sun through rituals, art, and storytelling, reflecting its enduring role as a symbol of life, warmth, and continuity. The sun's influence extends to agriculture as well, where its cycles dictate planting and harvesting seasons. Farmers have long relied on the sun's predictable patterns to grow crops, ensuring food security for communities. This connection between the sun and sustenance underscores its vital role in human survival and prosperity. Even in modern times, the sun's rhythms continue to shape our lives in unexpected ways. For instance, solar activity can affect satellite signals, influencing everything from GPS navigation to television broadcasts. While these disruptions are often seen as inconveniences, they also remind us of the sun's power and our reliance on its energy. As we reflect on the sun's rhythms and their impact on human life, we gain a deeper appreciation for the intricate ways our existence is tied to the cosmos. From the biological clocks ticking within us to the cultural traditions that bind communities together, the sun's influence is both universal and deeply personal. Now, let's turn our gaze to the sun's role as a source of energy, exploring how its light and warmth sustain life on Earth and power our modern world. As we shift our focus to the sun's energy, we uncover one of its most profound gifts to life on Earth. The sun is not just a distant star, it is the ultimate source of energy that fuels every living thing on our planet. From the tiniest blade of grass to the tallest tree, the sun's light is the foundation of life itself. At the heart of this energy lies photosynthesis, the remarkable process by which plants convert sunlight into chemical energy. Through this natural alchemy, plants produce oxygen and store energy in the form of sugars, creating the very foundation of the food chain. Every bite of food we eat, every breath of air we take, traces its origins back to the sun's radiant energy. It's a humbling reminder of how deeply interconnected we are with the cosmos, but the sun's energy doesn't stop there. Over millennia, humans have harnessed its power in countless ways. Ancient civilizations used sunlight to dry crops, warm their homes, and even tell time with sundials. Today, we've taken this relationship to new heights with solar power, a clean and renewable energy source that captures the sun's rays to generate electricity. Solar panels, gleaming under the sun's light, are a testament to human ingenuity and our ability to work in harmony with nature. The sun's energy also plays a vital role in shaping Earth's climate and weather patterns. Its warmth drives the water cycle, evaporating water from oceans and lakes, which then falls as rain to nourish the land. This cycle sustains ecosystems, supports agriculture, and ensures the survival of countless species. Without the sun's energy, Earth would be a frozen, lifeless world. Even beyond its practical benefits, the sun's energy inspires a sense of wonder and gratitude. Imagine standing under a clear blue sky, feeling the warmth of sunlight on your skin. That simple sensation is a reminder of the sun's constant presence, its steady flow of energy that has nurtured life for billions of years. It's a cosmic gift, one that connects us not only to our planet, but to the vast universe beyond. As we reflect on the sun's energy, we're reminded of its dual role as both a life giver and a source of inspiration. From the smallest leaf to the largest solar farm, the sun's light is a testament to the beauty and power of the cosmos. And as we continue to explore and harness this energy, we deepen our connection to the star that makes life on Earth possible. Now, let's turn our attention to how the sun's mysteries have inspired artists, writers, and thinkers throughout history. Weaving its light into the tapestry of human creativity. As we journey through the sun's influence on human creativity, we find its light and rhythms woven into the very fabric of art and literature. For centuries, the sun has been more than just a celestial body. It has been a muse, a symbol, and a source of endless inspiration. From the earliest cave paintings to modern masterpieces, the sun's presence has illuminated the imaginations of countless creators. In ancient cultures, the sun often took on divine significance. The Egyptians revered Ra, the sun god, as the bringer of life and the ruler of the heavens. Their art depicted Ra sailing across the sky in a golden boat, a vivid representation of the sun's daily journey. Similarly, the Greeks celebrated Helios, who drove his fiery chariot across the sky, while the Aztecs honored Tenochtitlan, the sun deity, at the heart of their intricate calendar stone. These artistic depictions not only honored the sun, but also reflected humanity's awe and reverence for its power. Literature, too, has been deeply shaped by the sun's mysteries. Poets have long used the sun as a metaphor for life, hope, and renewal. In William Blake's famous poem, The Tiger, the sun's fiery brilliance becomes a symbol of creation and wonder. Similarly, in Mary Oliver's works, the sun often represents the beauty and vitality of the natural world, inviting readers to pause and appreciate its warmth. Even in modern storytelling, the sun's cycles serve as a backdrop for themes of time, change, and resilience. Visual artists have also been captivated by the sun's ever-changing light. The Impressionists, like Claude Monet, sought to capture the fleeting effects of sunlight on landscapes, creating works that shimmer with life and movement. Vincent van Gogh's Sunflowers series radiates with the sun's golden hues, embodying both its energy and its ability to inspire joy. In more contemporary art, the sun continues to be a powerful symbol, representing everything from hope and renewal to the passage of time. The sun's cycles have also found their way into music and performance. From ancient hymns sung to honor the rising sun to modern compositions that evoke its warmth and brilliance, the sun's rhythms resonate deeply with human emotion. Its predictable yet mysterious nature has inspired countless works that celebrate its role in our lives, reminding us of the harmony between the cosmos and creativity. As we reflect on the sun's influence on art and literature, we see how its light has not only shaped our world, but also our understanding of it. Through the eyes of artists and writers, the sun becomes more than a star. It becomes a story, a symbol, and a source of endless inspiration. And as we continue to create, we carry forward this timeless connection, letting the sun's light guide our imaginations. Now, let's turn our gaze to the stars beyond our sun, exploring how its cycles connect us to the broader rhythms of the universe. As we venture further into the cosmos, the sun's steady rhythm becomes a guiding light in our search for life beyond Earth. Its stability, marked by the predictable ebb and flow of the solar cycle, plays a crucial role in shaping the conditions necessary for life to thrive. Without the sun's consistent energy and warmth, life as we know it would not exist, and this same principle extends to the stars beyond our solar system. When astronomers look for planets that might harbor life, they focus on stars that share similarities with our sun. These stars, often referred to as solar analogs, exhibit stable cycles of activity, much like our own sun. A star's stability is vital because extreme fluctuations in energy output can strip away a planet's atmosphere or create inhospitable conditions. The sun's relatively calm nature, punctuated by its 11-year cycle of activity, provides a model for what scientists consider a Goldilocks zone, a region around a star where conditions are just right for liquid water and potentially life to exist. The sun's cycles also influence the habitability of planets within our own solar system. For example, during periods of high solar activity, increased radiation and solar winds can affect the atmospheres of planets like Mars, making it more challenging for life to survive. On the other hand, during the solar minimum, the quieter conditions might allow for more stable environments. This delicate balance highlights how the sun's rhythms are not just a cosmic curiosity, but a key factor in understanding where life might flourish. Beyond our solar system, the search for extraterrestrial life often begins with identifying stars that mirror the sun's characteristics. Telescopes like the Kepler Space Telescope and the Transiting Exoplanet Survey Satellite have discovered thousands of exoplanets orbiting distant stars. Many of these planets lie within the habitable zones of their stars, where temperatures could allow for liquid water, a critical ingredient for life. By studying the sun's cycles, scientists can better predict how similar stars might behave and how their planets could support life. The sun's influence extends even further when we consider the role of solar flares and coronal mass ejections. While these events can be dramatic and powerful, they also serve as a reminder of the dynamic nature of stars. Understanding how the sun's activity affects Earth helps scientists develop models to predict how similar events might impact exoplanets. This knowledge is essential in assessing the potential habitability of distant worlds and determining whether they could sustain life over long periods. As we continue to explore the universe, the sun remains a beacon of possibility. Its cycles remind us that stability and change are both essential ingredients for life. By studying the sun, we not only deepen our understanding of our own place in the cosmos, but also expand our vision of where life might exist beyond Earth. The search for extraterrestrial life is a journey fueled by curiosity, and the sun's steady light guides us every step of the way. Now, let's turn our attention to the larger rhythms of the universe, where the sun's cycles are just one part of an intricate cosmic dance. As we broaden our gaze beyond the sun, we begin to see how its rhythms are woven into the grand tapestry of the cosmos. The sun's 11-year cycle is just one thread in a vast, interconnected web of celestial patterns that shape the universe. From the steady orbits of planets to the majestic rotations of galaxies, these rhythms create a symphony of motion and energy that spans the ages. Consider the planets in our solar system, each following its own unique path around the sun. Mercury races through its orbit in just 88 Earth days, while Neptune takes a leisurely 165 Earth years to complete its journey. Yet, despite their differences, these orbits are all governed by the same fundamental forces, gravity and motion, that keep the solar system in perfect balance. The sun's gravitational pull acts as the anchor, ensuring that each planet stays in its place, moving in harmony with the others. Beyond our solar system, the rhythms of the cosmos become even more profound. Galaxies, vast collections of stars, gas, and dust, rotate in a slow, graceful dance. The Milky Way, our home galaxy, takes about 230 million Earth years to complete a single rotation. Within this immense structure, stars are born, live out their lives, and eventually fade away, all while contributing to the galaxy's ongoing evolution. The Sun, with its cycles of activity, is just one of countless stars participating in this cosmic ballet. Even on the largest scales, the universe exhibits patterns and rhythms. The expansion of the universe, driven by dark energy, is a slow but steady process that has been unfolding for billions of years. Yet within this expansion, galaxies cluster together, forming intricate structures that stretch across the cosmos. These clusters, in turn, are part of even larger superclusters, creating a hierarchy of order within the vastness of space. The Sun's cycles remind us that change and stability are not opposites, but complementary forces. Just as the Sun alternates between periods of activity and calm, the universe itself is a dynamic place, filled with cycles of creation and destruction. Stars explode in supernova, scattering their elements across space, only for those elements to coalesce into new stars and planets. This endless cycle of renewal ensures that the universe is always evolving, always moving forward. In this grand cosmic dance, the Sun's rhythms are a reminder of our connection to something much larger than ourselves. They invite us to contemplate the beauty and complexity of the universe and to marvel at the forces that shape our existence. As we look up at the night sky, we are witnessing not just the light of distant stars, but the echoes of a universe in motion, a universe that sings with the harmony of countless rhythms, each one a part of the greater whole. Now, let's turn our attention to the Sun's legacy and how its cycles have shaped not just our solar system, but the very story of life itself. As we reflect on the Sun's journey through time, we see a story that stretches back billions of years, a tale of creation, transformation, and enduring influence. The Sun, born from a swirling cloud of gas and dust, has been the steady heartbeat of our solar system for over 4.5 billion years. Its cycles of activity, from the fiery peaks of solar maximums to the tranquil lulls of solar minimums, have shaped the environment around it, influencing everything from the planets to the smallest particles of dust. The Sun's legacy is written in the very fabric of our solar system. Its gravitational pull holds the planets in their orbits, while its light and heat provide the energy that fuels life on Earth. Over billions of years, the Sun has witnessed the formation of planets, the rise of life, and the evolution of countless species. Its cycles have left their mark on Earth's climate, driving changes in temperature and weather patterns that have shaped the course of history. But the Sun's influence extends far beyond our planet. Its solar wind, a constant stream of charged particles, interacts with the magnetic fields of other planets, creating auroras and shaping their atmospheres. Even the distant reaches of the solar system, where the Sun's light is faint, feel its presence through the gravitational forces that bind everything together. As we look to the future, the Sun's story continues to unfold. In about 5 billion years, it will exhaust its nuclear fuel and expand into a red giant, engulfing the inner planets and transforming the solar system once again. Yet, even in its final stages, the sun will leave a lasting legacy. The elements forged in its core, from carbon to oxygen, will be scattered across space, seeding the cosmos with the building blocks of new stars, planets, and perhaps even life. The sun's cycles remind us of the interconnectedness of all things. Its rhythms are a part of the larger cosmic dance, a dance that includes the orbits of planets, the rotations of galaxies, and the expansion of the universe itself. In this grand tapestry, the sun is both a participant and a guide, its light illuminating the path of discovery for generations to come. As we close this chapter of our cosmic journey, let us carry with us a sense of awe and gratitude for the sun, our cosmic companion. Its light has guided us through the ages, and its cycles continue to inspire wonder and curiosity. In the vastness of the universe, the sun's story is a reminder of the beauty and complexity of the cosmos and of our place within it. Now, let us drift among the stars, reflecting on the sun's rhythms and the endless mysteries of the universe, as we prepare to journey into a peaceful, dream-filled sleep. As we let the story of the sun's rhythms settle in our minds, let us take a moment to breathe deeply and feel the gentle pull of the cosmos. Picture yourself floating among the stars, weightless and serene, surrounded by the infinite expanse of space. The sun's steady heartbeat, its cycles of light and shadow, remind us of the harmony that exists in the universe, a rhythm that connects us all. Feel the warmth of the sun's light, even now, as it travels across the vast distances of space to reach us. Its energy, a gift from the heart of our solar system, has nurtured life on Earth for billions of years. As you drift, imagine the sun's rays wrapping around you like a soft blanket, comforting and familiar, yet filled with the mysteries of the cosmos. The stars above twinkle like distant lanterns, each one a sun in its own right, with its own stories and rhythms. Some burn brightly, while others flicker faintly, but together they create a tapestry of light that stretches across the night sky. Let their gentle glow guide you into a state of calm as you surrender to the quiet beauty of the universe. As you close your eyes, let the sun's cycles remind you of the ebb and flow of life itself. Just as the sun moves through its phases, so too do we experience moments of energy and rest, light and shadow. Embrace this natural rhythm, allowing it to carry you into a deep, peaceful sleep. In this moment, you are part of something vast and timeless, a universe that hums with the energy of countless stars and the quiet whispers of cosmic winds. Let the stillness of space envelop you as you drift into dreams filled with the wonders of the cosmos. Thank you for joining us on this journey through the mysteries of the sun's 11-year rhythm. If you enjoyed this cosmic sleep story, don't forget to subscribe for more journeys into the universe and share your thoughts in the comments below. Until next time, may your dreams be as boundless as the stars. Good night. As we bring this cosmic journey to a close, let the tranquility of the universe linger in your thoughts. The sun's rhythms, its cycles of light and shadow, remind us of the delicate balance that exists in the cosmos and within ourselves. Just as the sun moves through its phases, we too find moments of energy and rest, light and darkness, all part of the beautiful dance of existence. If this exploration of the sun's mysteries has brought you peace and wonder, consider joining us for more cosmic sleep stories. Each journey offers a new opportunity to drift among the stars, to uncover the secrets of the universe, and to find solace in its vast, timeless beauty. Don't forget to subscribe to our channel so you never miss a moment of these celestial adventures. Share your thoughts in the comments below. What part of the sun's story resonated with you the most? Your insights and reflections help us create more stories that inspire and soothe. And as you close your eyes tonight, let the stars above remind you of the infinite possibilities that await. Thank you for being part of this journey, and may your dreams be as boundless as the cosmos. Until next time, good night and sweet dreams.